Hello there. I'm incompatibility, but I would like to talk to you today about using control voltage into audio effect units, such as delay, filter, distortion, and others. Sadly, I am not compatible with this reality, so Brian from Robots Are Red will take us the rest of the way. Take it away, Brian.
All right, well, thanks, Incompatibility Bot. To best demonstrate this, first I'm going to start with 2 HP's delay, which has a typical input, output, time, feedback, and mix controls, each with CV controllable inputs. So it's a pretty straightforward delay unit, so you're not going to be thinking about that when we're looking at what it's doing with the CV input. So let's see what that looks like when we input a gate from my keyboard into the delay unit, and then we'll put the delay output back into the oscilloscope so we can see that, and that output is going and controlling a filter. And we'll turn the mix all the way up, feedback all the way down, and then we'll have the time at about 50 so we could see it separate from the gate here. So we'll play a note. So we can see we're getting a trigger. And then on the release, we're getting a negative trigger. That's because this input is AC coupled and not DC coupled. DC coupled handles control voltages, where AC coupled is meant to handle audio inputs, and it kind of filters out those slower sound waves. So it thinks the sound is coming through when the gate is high, and it stays still there and it doesn't oscillate, so it doesn't think the sound is coming through anymore. So it goes back down to 0, so it only picks up that quick transient. And then it does the same thing when we release, because we have another quick transient, but it's going downward, so it goes into the negative direction. But we get an interesting effect here when we start playing with the feedback. And then when we release it, if we have enough decay time on our envelope, we can see it goes the opposite direction and gives us a different effect on release. We play with the time, and the feedback amount, even the mix amount, and get these interesting, almost LFO waveforms that slowly decay. Now let's take a look at it with an LFO. So here we can see I have a slow-moving triangle wave, and it is not picking up in the delay at all. That's because the wave is moving too slow and there aren't any quick transients that are able to pick up. But if we go just fast enough, we keep speeding up, it's going to start picking it up. But it's doing interesting things to it. So if we play our note, let's just play a quick pattern here. So we up the speed here. Let's turn the feedback all the way down and just see what it's doing. So it's kind of following the wave. The slower I go, the less it is. So let's see, I go faster, and now it's following it much closer. That's actually an interesting effect. Let's add some feedback. But now, let's take a look at this with a ramp up. Now we can see it's going slow, but it's going to notice on those transients and register that change. Same thing with a ramp down. But you notice with the ramp downs, we get a nice positive trigger. With the ramp ups, we get a negative trigger because of the direction of the transient. Now let's look at this with a stepped sequence random source, sample and hold. Right now I have just random sample and hold, like values coming from PAMs here, from channel 1, from any value from 0 to 100 of the 5 volts, and it's going to be all positive. So you can see here, it's picking up those transients, and the bigger the jump, the larger the wave we get. And again, it depends which direction the transient's going to direct our trigger which way to go. Next, we'll be talking about using CV into the audio inputs of audio filters to see what that sounds like. Right now I'm using After Later Audio's Filthy filter, which is actually a pretty clean filter, with your typical cutoff, resonance, and I'm choosing this because of the simple layout. It has a notch, low pass, band pass, and high pass filter outputs, so we can see what all of those look like with these waveforms. So now we want to see this with an audio filter and how it works with that. So I have my gate coming into channel 2 and out into the audio filter. So it's my keyboard gate, and we'll see what comes out of that and into channel 1. I'll put it in low pass filter to start. So we can see we're getting a short trigger on our gates. We know when the gate's happening, so we don't really need to see that. Let's just look at what our CV output is. So you can see the tail is much longer on this than it was on the delay. It's still going positive on the high gate and then negative when the gate releases. And the cutoff, no matter which way we put it, seems to not really have an effect. And the resonance only does once we get into audio levels. That's because we're using a low pass filter here, and this is actually just a very low, slow frequency playing. So it's not filtering that out because it doesn't hit that cutoff threshold. And let's see that with the sequence playing. So we see we're just getting those releases and those hits, and there's not too much else to it. Let's see this into the filter again to hear it. Okay, now let's take a listen to this with the high pass filter, which should filter out most of the noise because it's only picking up the higher frequencies rather than the lower frequencies. So right now you can see there's nothing because our cutoff's at about 12 o'clock. If we go back with the cutoff all the way down, it's where we should hit that sweet spot of seeing anything at all. And we're just seeing the short transient. So it's giving us these tiny little teeny, not even trigger level triggers. And that's about it for the high pass filter. We get a little bit more shape to it when we turn the resonance up, you can see, versus down. Let's look at the bandpass filter now. So it should pick up more on the lower end. Let's look at a sequence with more gates here. It's not doing too much with the bandpass filter. That's not very exciting. Let's look at the notch. That's giving us some interesting shapes here. Let's look at it with less gates again. So we can see a nice long tail on this one as well. And it gives it a little bit of that shark tooth effect. Maybe that's the resonance. It is the resonance. Gives it much sharper transient. Now let's see that with an LFO wave. So here, you can see our LFO wave going. Let's see what this sounds like. So we can see it is following it a little bit. This is with the notch filter still. It's kind of toning it down. A little more resonance is adding some craziness to it. Let's look at back with that low pass. It is following it with a more interesting curve to it. That same fall-off curve it had before. But it is following the triangle, which is interesting because the delay did not. Well, let's look at with the ramp up. We're getting similar follow effect, but with a more exponential looking curve that settles at 0 instead of positive. Now let's see a ramp down. So again, it's kind of following the LFO, turning it unipolar, and giving it a slightly more exponential curve. Again, and with the high pass, we'll only get something when we have the cutoff all the way down, and it's going to be a shorter trigger, as we can see. And with the band pass, we're not going to get much of anything again. And we already saw the notch. But let's look at it again. And now let's take a look at this with our random sequence from hymns. So we can see we're getting those nice little envelopes off the steps. And it seems like it's following each one pretty well with the notch. Let's look at it with the low pass. Oh, and the notch should add us that sharp tooth when we play with the resonance. Let's look at this alone. It does. And again, it jumps about as high as the transition in the note. So a bigger jump will give us a bigger triggery envelope-y thingy thing. Next, we'll take a look at CV through distortion. Right now I'm using Noise Engineering's Terza Ruina, which has 3 different distortion sort of effects in it, and we can see how each of those affects the CV. And let's see how these look with our keyboard gate. So this should act similar, yes, to the delay, where we get a short trigger on the hit, and then on the release. We turn the gain up. It's not really changing too much until we get all the way up and we get into that distortion noise territory. Let's look at the wave closer up. So it's an interesting shape to it. It's a very quick shape. Let's see how it changes with the distortion. So you kind of sharpens it a bit. It just gets a little smaller as we go down because it's kind of bringing the volume down a little bit. So it's not really doing too much. Let's take a look at it through the FF distortion. It's a little sharper. We have a ramp down looking shape here. As we turn it up, it just gets a a little bit bigger. But that's about it. It's just an interesting shape. And now we'll look at it through the fuzz. What does CV do through fuzz? So this seems to be doing the most. So it's a kind of smoother little envelope. Look and see how quick it's going here. So you can see it's rounding out as we turn it up. And it's turning into an interesting sharky tooth sort of thing here. It's interesting it has a little negative at the beginning. Again, noting that this is very quick, but it is an interesting shape. Now let's look at it with the ramp up wave. So again, you can see it's on those transients, but it is giving us an interesting, more distorted shape that is not just a simple up and down. And that's about it for the distortion. And now we'll take a look at the CV through the popular successor to Mutable Instruments Clouds, Beads. Now here I have my gate for my keyboard again, going into Beads, and the output of that is going back into the oscilloscope and back through to the WASP filter again. So we can see here, this reads it a little differently. I have this totally dry, so it should be mimicking the gate coming through, but it's not because it has the AC coupled input. So let's look at just the wave itself. So we can see this is interesting. It's going net reverse of how the other ones acted, where it's giving us a negative trigger on the high gate and a positive trigger on the low gate. But it is an interesting curve to it with a nice long tail. Now let's see if we can play with this with beads, seeds, and time. What does reverb do? Kind of turns it into a wave a little bit with the reverb, which is interesting. Play with the shape a little bit. This turns into an interesting LFO with the reverb all the way up. Not all the way up, but playing with it a bit. But not more than 3 times. Okay, now let's take a look at this with our LFO output. So it's not giving us too much here other than beads just kind of playing with itself. So let's take a look at the ramp up. So we can see these interesting waveforms coming through here. Let me turn the reverb. So I seem to get the best results from the trigger here. So let's try it from this sequence from pans. So So this is getting us some interesting craziness that's kind of on sequence. This is a decent setting I got here for this, maybe a little fast. But now we can play with the modes here, and it gets a little bit crazier the longer buffer time we go and the lower quality we go. So this one's real interesting. Okay, so after listening to all that CV affect the WASP filter's frequency, let's see how that CV comes out as triggers through things such as the delay in beads and data bender. So right now I have a gate of my CV going to peaks to trigger a drum. So anytime I hit a key, it's triggering my drum as well. I also have that trigger going into the oscilloscope here and then down into the delay. So we can see how this delay affects other triggers. I have the delay going into the trigger for channel 2 of peaks, which I have set as one of the FM drum settings that just sounds kind of more hi-hatty. Also, I have my channel 1 steps from earlier going into peaks, my Baker edition, to control the pitch of that hi-hatty sound to make it a little bit more interesting. So we hear one click delayed. So this could be interesting, you know, for getting a nice, just single delayed trigger. Let's hear it in the sequence. Steps into the time here, so I don't have to constantly turn that. So I have a random step every 4 beats that gives us a different time. Okay, so now we see how that works with the delay, making interesting rhythmic beats tied to your gates. And let's see how this works with beads. So here you can see I have the gate trigger into beads right now, and I have it fully dry with the feedback and reverb all the way off, and we can see what this does. So again, we're seeing that interesting positive and negative trigger here, but it's giving us interesting triggers. So let's go more wet and see what this can do. Give us a little bit of feedback here. Play that sequence. And I'm not sure how different this is than just using the right output trigger setting on beads. Now let's take a look at Data Bender. So here, first let's put Data Bender completely dry and see what we get. We just get we get a trigger on both the gate and the release. Let's play the sequence real quick. Doesn't give us an interesting pattern. Now let's mix it in with some different things. Ooh, that's interesting. Those same steps from earlier into repeats. repeat, so it's like I'm setting this knob differently each time. Now let's take a look at this with it bend up. See if it does anything different. A little more unpredictability. Look at really quick in the micro mode. That's going to give us slower, so we probably don't want that way. This way is going to give us faster. That's it for this video. I'm using CV into audio input